Hello my dear students. In the previous tutorial we completed the chapter limit, that was from the statistics second part, fourth chapter. Today we will move on to the next chapter, which is very much dependent on the concept of limit, and it is one step ahead of it. Welcome to the subject of statistics, class 12th English medium, part 2, chapter 5, that would be differentiation, presented to you by Vitan sir. The question arises is, what is differentiation? Let us understand it with an illustration here. I will take an equation here, that is fx is equal to 2x plus 1, where we will take x is equal to 2. Now we will apply the concept of limit here and see what we get. I will take value of x and value of fx. I will take x as 2.1, and when I put 2.1 into my equation, I get 5.2 as the answer. Then when I put 2.01, I get 5.02. Similarly, 2.001 gets me 5.002. Now, I will depict what I changed in the values of x, and similarly I will also check what changed in the value of fx. That means in this concept we are actually calculating the changes made in our variable with respect to changes made in our answers. I will consider the fx as y here, changes in the x as delta x, and changes in fx, that is changes in y, as delta y. When I put the symbols, it becomes easier to put them in the functions afterwards. Okay, so when I made the change of 0.1 into my x was originally 2, and when I take 2.1 as x, the difference is 0.1. So fx, we know that if we put 2 into the function, we will get fx as 5. So the difference in fx after taking 2.1 was 0.2. Okay, so when I change x by 0.1, I get the answer as 0.2. When I change x by 0.01, I get the answer 0.02. When x changes by 0.001, the answer is 0.002. That means when the value of x is taken nearer and nearer to 2, y goes nearer and nearer to 5. Here the value of delta x, that is the changes in x, goes nearer and nearer to 0, and similarly changes in delta y also goes nearer and nearer to 0. But what is differentiation is, it is the ratio of delta y to delta x that is depicted by something like that if I take 0.2 upon 01 or 0.02 upon 001 or 0.002 upon 0.001, the answer remains constant, that is 2. So what I try to say here, that the difference in the function with the changes in the variable x is always constant, and this constant ratio, that is this ratio, is called incrementary ratio. Yes, my dear friends, this ratio has a name, that is incrementary ratio, and our concept of differentiation is solely based upon this particular ratio. The limit of this ratio, that is delta y upon delta x, can be depicted as dy upon dx and can be written as follows. That would be dy upon dx is equal to limit delta x tends to 0 delta y upon delta x. Yes, as we saw in the illustration, the value of delta y tends to 0 and delta y upon delta x proportion is always constant. So the answer of that proportion, that constant value, is same for any equation, and so that equation's constant value is called the derivative value. So dy upon dx is called derivative of the function, and the method of calculating this is called differentiation. So basically the differentiation and derivative are connected, which is connected with the incrementary ratio, which is the ratio of the difference in the function with the difference in the variable. Uh, Let us understand it, try to understand it differently. Let us take another kind of a example to get it simply. This time we will suppose fx as y and take x is equal to a. So fx here changes into fa. So the variable is x and the function is f. When I take x as a, the function becomes fa. And when I change the my value of my function from a to a plus h, the function naturally becomes f a plus h. Now this much is simple. So what we do next is change in x, that is delta x, change in fx, that is delta y. So the change in x from a to a plus h, the difference between those two is just h. So change in x, that is delta x, will be replaced with h here. While when we make a when we want to find the difference in the value of the function, we need to make a difference of the two functions found. So delta y here will be f a plus h minus f a. So when we put this two, delta y and delta x, into our original dy upon dx, we will get dy upon dx is equal to limit h tends to 0 as delta x is replaced by h, f a plus h minus f a as delta y is replaced with this value, divided by delta x is replaced with again h. So this is the simpler format of the differentiation function which we are going to use in practical. So delta y upon delta x is just a theoretical form. This is the practical form which we will be using from now on to define differentiation in a theoretical term. Let f be the function from a to b and a belong to a, where a is an open interval of r, that is the real values. If limit h tends to 0, f a plus h minus f a upon h exists, then this limit of the function f is called derivative at x is equal to a, and it is denoted by f dash x. The process of obtaining derivative of the function is called differentiation. So my dear friends, once again in a nutshell, differentiation is the ratio between changes in the function with the changes in the variable. So that is in a single sentence, changes in the function to the changes in the variable. But when we define it properly, systematically, this is the length of the definition. So write down all of those things which I have taught you in this slide and try to remember it. Next time we will come up with some practical examples to understand this theory in sums.